Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, if you can recall from our previous lesson, we were looking at characteristics and features found within the different layers of the atmosphere. We looked at the three main zones that the atmosphere can actually be divided into. We looked at the troposphere, which is the first layer going from the surface of the Earth upwards. Then we looked at the stratosphere, which is the second layer, and the ionosphere. Within the ionosphere, we also had the other important zones that come in, the zones known as the mesosphere, the thermosphere, the exosphere. We were able to only complete characteristics or features within the first layer, and in our lesson today, we'll continue on with the characteristics and features of the second layer, which is the stratosphere, as well as the third layer, which is the ionosphere. Before we move on to looking at the characteristics in the two other layers that we have not looked at, let's recap and revise on what you have contributed in terms of the answers for the first layer, which is the troposphere. The task or the activity that you were asked to complete in our previous lesson was to look at the table, and from the table of information, you were supposed to put down the height in terms of range in kilometers for those different layers, to how far do they go, and you were also supposed to make note of some of the features and main characteristics found within those layers. Okay, looking at what we have covered already, we are now revising on the first layer, which is the troposphere. The answers that you had, it extends from about 0 kilometers, or from the surface, up to 18 kilometers at the equator. And at the poles, it varies between 0 to about 8 kilometers. That is filling in the second column for the first layer of the atmosphere, which is the troposphere. Okay, we move on. Beside that, you were able to also give some of the different characteristics. Let's look at them quickly, and then we'll move on to the characteristics of the other layers. You mentioned that the troposphere was actually the first layer of the Earth's surface, and that is correct. It's the first layer when we are zoning the atmosphere. You also mentioned that the troposphere, contains 80% of the air, and that is correct. The troposphere is also the zone of weather. That is where clouds are formed, water vapor is actually present, rain falls, etc. All of those occur within the first layer of the atmosphere, which is the troposphere. Therefore, the troposphere is also referred to as the zone of weather. You also mentioned that within the troposphere, temperatures generally decrease with altitude. So for every 1,000 meters you go up, within the troposphere, for every 1,000 meters you go up, temperatures tend to decrease by about 6.4 degrees Celsius. So approximately every 1,000 meters you go up, temperatures decrease by about 6.4 degrees Celsius. And that goes together with one of those important characteristics in the troposphere where we say temperatures decrease with altitude. Another of the characteristics which was actually brought up was the fact that the troposphere is the zone of life. We have plants, animals, human beings, etc., which are found within this particular zone, and that's the troposphere, the zone of life. Moving on, another important characteristic to do with the troposphere is that pressure, this time, pressure decreases with altitude. The higher up we go, pressure tends to decrease. That is one of the characteristics of the troposphere. Also, one of the students mentioned that the troposphere contains most of the water vapor, also dust and clouds. Knowing that the troposphere is the zone of weather, obviously, clouds would have to actually be formed and found within this zone or layer. Similarly, water vapor. Most of the water vapor is actually found within this particular layer, the troposphere, as well as that dust also is contained and found within this layer, the troposphere. Another important characteristic of the troposphere is the movement of air, and the movement of air is vertical as well as horizontal, meaning air rising up, and that occurs within the troposphere where air is vertical in terms of its movement, and as well as that, within the troposphere, the air moves horizontally. So when we're looking at the winds, the moving from one place to another, especially if we are dealing with the land and sea breeze, during the day, the land heats up quicker than the sea. During the night, the sea cools down slower than the land, and the movement of air from low pressure area to high pressure area, most of those would be generally horizontal movement. So within the troposphere, air movements are both vertical and horizontal. Okay, now we look at the extra information which I have also put in that we can also make note of as some of the characteristics of the troposphere. And one of those is that of the jet stream. We all know what a jet stream is. Okay, when we're making reference to jet streams, they're basically westerly winds. They're winds that blow at a very strong force or velocity or speed. And because they blow at that very strong speed or force, they are actually referred to as jet streams. So if you look at a jet flying, a jet has to have a lot of power to actually travel fast. And the flow of air, especially horizontal movement of air at a certain altitude within the troposphere, is referred to as the jet stream. Another importance about this particular movement of horizontal air mass, the jet stream that is that pilots may use this to help them in terms of flying time, to go from one spot or one place to another. And these particular air masses, which are referred to as the jet stream, they are different, or there is pockets of them found mainly within the mid-latitude regions. Temperate regions, within the temperate and the polar regions, that's where pockets of air, which are referred to as jet streams, that blow at certain altitude and that blow at a very fast speed. So the pilots flying jets can also use this to help them with their flying time. That is also another characteristic that we need to make note of, found within the troposphere. One of the students also mentioned that within the troposphere, that's where most of the oxygen is actually contained or found. That is important. Because of this, life is also able to not adjust only, but live within this zone here, the zone troposphere. One of the students also mentioned the vigorous mixing of air transpiring. Within this particular zone, there is a vigorous mixing of air that actually transpires, correct, as a characteristic feature of the troposphere. We also had someone who mentioned that this is the layer that contains approximately about 58% or 58.4% of the total mass of the atmosphere, and that is definitely correct. And finally, but not the least, we also have within this particular zone, this was not mentioned, but I thought that I should put that up so that you are aware that also within the troposphere, this is the zone where the transmission of radio waves also occurs. In order for us to have communication, we are able to listen to the radio and watch television and etc. The transmission of radio waves occurs also within the troposphere. So those then are some of the characteristics that you had given in our last lesson. Anyone with any queries or questions with regards to those characteristics? No queries? No questions? Okay, we'll move on now. And if there are no queries or questions, I'd like us now to look at the completion of the table. And this time we will look at the second layer of the atmosphere, which is the stratosphere. We look at generally the height that it extends up to, and also the features and characteristics of this particular layer. Okay, we have the stratosphere. We'll start off first by the height. Give a range in kilometer, generally, of this particular layer, the second layer. What is the height in kilometer? This is from our discussion in our last lesson. So, Catherine, what do you have as the height for this particular layer?
20,
About 20
20 to 50 kilometers.
to 50 kilometers. Okay, good. Because according to our information, we wanted to look at a range in kilometers. So here we are looking at approximately the second layer of the atmosphere, the stratosphere, that is, goes from about 20 kilometers to 50 kilometers. We are going vertically, we are going up. Anyone maybe has a different answer to what is given here? Did you all get approximately about 20 kilometers to 50 kilometers? Yes, okay, good. So here goes, then we move on. The next thing now that we are going to make a list of is a list of the characteristics of this particular layer. So we'll start from the front here and we'll go around. Gideon, you give us one of the characteristics of this particular layer, the stratosphere.
Temperature increases with height.
Okay, so here goes. We double check. One of the characteristics is that temperature increases with height. Do we agree with that characteristic in the second layer of the atmosphere, stratosphere? Yes, definitely. If you can look at the graph that we have looked at already, you will find that, yes, temperature does increase with height in this particular layer. Okay, any other characteristics, Moses? The next one?
Second layer of the Earth surface, above the Earth surface.
Okay, very good. We're looking at second layer. It is definitely the second layer from the Earth's surface going up. We know the first layer is the troposphere, and the second layer is the stratosphere. Next characteristic.
A strong horizontal movement of stratified or layered air.
Okay, very good. Within this particular layer, the stratosphere, there is strong horizontal movement of stratified or layered air. In the first layer, which is the troposphere, we had vertical as well as horizontal movement of air. In the stratosphere, it is mainly the strong horizontal movement of stratified or layered air. Okay, that's an important characteristic which comes here for the second layer. Brendan?
Temperatures are approximately constant at negative 57 Celsius degrees.
Okay, temperatures are
At negative 57 Celsius degrees.
constant at negative 57 degrees Celsius. Okay, note another characteristic, temperatures are actually constant at negative 57 degrees Celsius. We double check. We're happy with this characteristic? Yes? Okay, Catherine?
This layer acts as an upper atmospheric heat source.
Okay, this particular layer, it acts as an upper atmospheric heat source. Okay, and that is also an important characteristic of the second layer of the atmosphere, which is the stratosphere. Shelley?
The ozone layer.
Okay, very good. It contains this important layer, which is known as the ozone layer. Kiran?
No clouds are found in this region.
Okay, no clouds. Very good. We have all the formation, cloud formation, etc., which are found within the troposphere. Within this region, stratosphere, no clouds are found or also formed. Caleb?
No vertical movement of
Okay,
the
very good. We have no vertical movement. We can also include with here the strong horizontal movement of stratified or layered air. There is no vertical movement.
It's the layer of photochemical absorption of ultraviolet radiation.
Layer of
Photochemical absorption of ultraviolet radiation.
okay, layer of photochemical ultraviolet radiation.
Photochemical absorption.
B-P-T-I-O-N. Okay, sorry, not full stop here. Okay, the layer of photochemical absorption of ultraviolet radiation. Okay, so in other words, this is the layer that absorbs most of the photochemical ultraviolet radiation. And that's where the ozone layer comes in also. Okay, good. We move on. Any other characteristics that we can include? Silo?
There are no clouds because temperatures are well below freezing point.
Okay, here we have no clouds and we can expand. Reason being that temperatures are well below freezing point. Okay, good. You can expand with the point given here. Any others? No? Mason?
There's no life found in the stratosphere.
We sure no life?
Yeah.
You 100% sure that there is no life? Okay, according to Mason, no life. We'll put that down because he said he's 100% sure there's no life within this particular layer and upwards. We're thinking of all those extraterrestrial. Right at the back, Frank. Any more to be included here? No? Christopher? Okay, let's look at what is up here. And then from here, you can also make note of the characteristics into your exercise book. Okay, we'll start. We're looking at the second layer now of the atmosphere. We said that it is between 20 to 50 kilometers. We can also go down as far as 18 kilometers because we said that the troposphere is from about 0 to 18. So from 18 to about 50 kilometers, and if we did say 20, that is still okay. So a range between perhaps 18 to 20 kilometers to 50 kilometers above the surface, that's where we have the second layer of the atmosphere. Okay, some of the characteristics that we have looked at already. You mentioned that definitely temperature will increase with height. In the second layer now, it changes. In the first layer, temperature decreases with height. In the second layer, that's stratosphere, temperatures increase with height. It is the second layer of the atmosphere. There is strong horizontal movement of stratified or layered air in this particular zone. Temperatures are constant at about negative 57 degrees Celsius, another important characteristic of this particular zone. This particular layer, the stratosphere, also acts as an upper atmospheric heat source. This particular heat source, if one has to explain how that is actually possible, we can look at perhaps the ozone layer. And with the ozone layer, the ultraviolet radiation is actually absorbed. And from the absorbing of the ultraviolet radiation, that is where temperatures then tend to increase. And the temperature then can act as an upper atmospheric heat source for that particular zone or layer. Okay, we also note this is the layer where the ozone gases are actually formed and found, and those ozone gases then will contribute to the formation of the ozone layer. This particular layer is very important because this layer, we already mentioned, absorbs. It absorbs the ultraviolet radiation. The radiation from the sun, if 100% of it comes straight to the surface, then it becomes very, very dangerous for living cells. Because of the ozone layer and the absorbing of the ultraviolet radiation, most of the poisonous gases which are actually sent from the sun is actually absorbed. And only those that come through are the ones that are able to maybe contribute to process of photosynthesis. And not only that, humans, we need vitamin D, is that right? From the sun's energy. So the radiation that comes through are those that are useful for humans. Those that are actually absorbed are the ones that are poisonous. And that is the important thing about having this particular layer, which is the ozone layer. A worldwide problem today that is actually occurring is that humans, we are now creating chemicals and pollution to the atmosphere, and those chemicals can also contribute to the breaking down of the layer. And that is where there is threat of a hole being created over the Antarctic, and that hole is allowing then the radiation from the sun to actually come through, and a lot of people fear about that, and there is a lot of talk about pollution into the atmosphere and the need for the reduction so that we don't destroy this particular layer of the atmosphere. Okay, here we also note in the second layer there are no clouds, obviously. There will be no clouds because we're already away from the zone of weather. There is no vertical air movements. There's mainly horizontal air movement, and Mason did say that there is no life within this particular layer. Okay, good. Any questions with regards to the characteristics you have given on the second layer of the atmosphere? No questions? Okay, if there are no questions, then finally, we look at the last layer of the atmosphere, and that is number 3, ionosphere. Looking at the last layer now of the atmosphere, the ionosphere. First of all, let's look at the height. Anyone tell us to what height does it start and where does it end? Rebecca, right at the back. What is the range in kilometers you've given for the ionosphere?
80 to 250 kilometers.
Okay, 80 kilometers to 250 kilometers. Any others? We all happy that it's 80 to 250? No? Someone said no. Kiran, you might be correct. We're happy that it's about 80 kilometers because in the second layer we said it is from 20 to 50. So in the next layer, Kiran? Okay, Kiran's going to give us a possibility here.
If 50 to 250.
Okay, we're looking at 50 instead of 80 kilometers to about 250. Are we happy with 50 kilometers then? Yes, okay, so perhaps we'll go from 50 because you see we've started off by looking at 20 to 50, and then if we don't go from 50, so what is that particular zone that is between 50 to 80? It comes in together with the last layer, which is the ionosphere. So we will make that correction and we will say from 50 kilometers instead of 80. Okay, we happy with that range now? Okay, in some books, I have already mentioned, different books will give you different ranges for the maybe height of the different zones of the atmosphere. We're making our info, or we are coming up with our information according to what we have already placed here. So we're going from 0 to 18 kilometers, then we start from about 18 to 20 to 50 kilometers, and now we are going from 50 to 250 or 50 to infinity to the top. Okay, so perhaps this height here we might need to also consider if we're looking at the last or the third layer of the atmosphere. Okay, let's look at the characteristics. Ovio, characteristics. Give me one of the characteristics of this particular zone here, the ionosphere.
The layer contains ionized gases.
Okay. This is the layer which contains ionized gases. Christopher?
Directly exposed to the sun.
Okay, the layer which is directly exposed to the sun. Okay, very good. Any other characteristics, Frank?
Absorption of solar radiation.
In this layer also, solar radiation is actually absorbed. Not all of it, some of it, because some actually need to come through the surface as insulation. Rebecca, any other characteristic of the ionosphere?
Layers of increased electrical conductivity.
Layers of increase, or it is a layer of increased electrical conductivity. Any other characteristics, Silo, of the ionosphere, the third layer of the atmosphere?
It reflects radio waves back to Earth, making long-distance communication possible.
Okay, very good. Okay, this layer, very important. Within that layer also, that's where the reflecting of radio waves are actually carried out back to the Earth's surface, and that makes it possible for communication to actually take place. So the reflection of radio waves back to the Earth's surface occurs within this layer also, the ionosphere. Is that all? So where does the mesosphere, the thermosphere, the exosphere come in? Where are those different layers or zones found? They're also found within the ionosphere. So another characteristic that you could also make note of would be within the ionosphere, it can be further subdivided into the mesosphere, the thermosphere, and the exosphere, and that division is mainly according to difference in temperature. So within the ionosphere, you can further subdivide according to temperature difference into the mesosphere. Mesosphere is the layer directly above the stratosphere. And then above that comes the thermosphere. And then above that comes the exosphere, of which all of those occur within the ionosphere, the third layer of the atmosphere. That is also another characteristic that perhaps you could make note of, the subdivision according to temperature zones into the mesosphere, thermosphere, and exosphere. The ionosphere can be further subdivided Okay, we'll include that, and Aurora would be another one we can include. And Ovio is going to explain what the Aurora is. Okay.
The aurora referred to as the northern lights. They extend to about up to about 100,000 kilometers. Sorry, 1,000 kilometers.
Ovio explained a little bit about what the aurora is. For the rest of you, if you'd like to find out a little bit more information about that, you could check out the encyclopedia or check out other sources where we can get more information on this feature, the aurora. Okay, with that information, I'd like us now to move on to the completion of the following activities. And whatever we do not complete within our lesson today, you will be required to complete those activities for your homework and then bring back the answers for us to go through and double check. Okay, looking at the activities that I'd like you to work on, 2 lots, of which the second activity is mainly to do with definitions. We've looked at a couple of words here, and I'd like us to be able to know the definitions of those words also. But the first one, the first question, why do jet planes especially fly at the base of the stratosphere, or simply at the highest point of the troposphere? That's question number 1. See if you can answer that. Why do jet planes fly at the base of the stratosphere? Question 2 is basically to do with definitions, and these are some of the words that we have already used in our characteristics and also the zones of the atmosphere. And I'd like you to find definitions and also write the definitions in your exercise book. The words are define atmosphere, troposphere, stratosphere, ionosphere, tropopause, that's the next word to be defined, and stratopause, that's the next word to be defined, mesopause, mesosphere, exosphere, aurora, and ions. We've looked at aurora and ions as characteristics found within the third layer. Do we know what they are? Your task is going to see if you can find definitions, and you bring back those definitions for us to correct in our next lesson. Okay, I'll go back to the list of words. I'll give you time then to make note of that, and you can start off with those activities as soon as you've copied down the information. Have you made note of the words on the first slide here? Okay. The next lot of words, still for definition, those 6 words that appear on that slide now, make note of it. Oh yeah, definitely, yes. It was not mentioned, but it definitely does contain meteorites. You don't usually find the meteorites in the stratosphere. Most of it is actually contained within the ionosphere and further up. So definitely you could include that. Okay, you can discuss for the answer to question 1, and then maybe at least do the first 5 or 6 definitions, and then the others we may complete, or you should be able to complete for your homework. Discuss on the first question and the first 6 definitions for question number 2. Oh yeah, definitely. This is my copy. I'll give you maybe one from the office. I've got a couple of copies there. Yes. I did not bring any. No, nothing. Okay, we are able to only correct question 1, and I'll leave exercise 2, which is all the definitions for you to complete. You come back in our next lesson ready for us to check on those. Okay, anyone got an answer for why you think jet planes fly at the base of the stratosphere? Anyone got an answer for that question? Susan, what do you think? We've looked at all the characteristics of the different layers of the atmosphere already. Perhaps by looking at those different characteristics, it might be able to help you with answering that question. Okay, Susan is going to give a try for that answer.
Because aircrafts usually fly in the jet streams, and that is located within the stratosphere, base of the stratosphere.
Okay, you're partly correct in saying that. Yes, definitely. Not all the planes actually fly within the base of the stratosphere. Most of the planes, jet planes especially, they are pressurized so that they go to a certain height. And if they go over the certain height, then they can tell from their instruments or instrument in the plane, and they know that they cannot go beyond that. So all planes, jet planes especially, are pressurized to a certain pressure. Some planes can fly very high, the other planes perhaps not so high. The twin otters, the twin otter engines, they are not pressurized. So you see, they cannot go above the clouds when they are flying. That might give you an answer. The answer that Susan has given on the jet stream is definitely correct. Some planes like to fly in that altitude because pockets of air, horizontal movement of air masses are found within there, which are known as the jet stream. So some of the jets, especially in the mid-latitude, use that to travel efficiently from one point to the other, saving fuel and etc. So one reason possible. What could be another possible reasons? Or reason, not reasons, but reason. Catherine, what do you think?
Jet planes fly at the base of the stratosphere because here high-speed horizontal winds exist, known as jet streams, and because they blow eastwards or westwards at different levels, they can be used to help jet aircrafts
Okay,
travel.
so that's further explaining and clarifying what Susan has said. And that's the same thing. Well done, yes. There's one more reason for why planes fly within that area or zone. Pressure? Christopher?
To avoid the up and down movement of air.
To avoid the?
Up and down movement of air.
Okay, partly correct, yes. But not only the up and down movement of air or the vertical movement of air, it also avoids what is actually found within the Troposphere? Clouds. Thank you. Clouds. You see, the clouds then, the movement of air causes what we call turbulences. So to avoid all of those air movements and clouds and turbulence, the jet planes fly a little bit higher, perhaps above the limit of the troposphere, just below the base of the stratosphere, so that will avoid any turbulences while they are actually traveling. So it means they can get quicker from one point to the other without so much turbulence. So we come back to the twin otters, the twin otter engine planes. They cannot fly above because they are not actually pressurized to fly in that altitude. So they fly and they have to go through clouds and etc. and they experience, or you would experience, a lot of turbulences because those planes fly within that zone. They cannot go further up. But the jet planes, they can. And the reason for why they would do that is to avoid the turbulences, the clouds especially. Not only that, some of the jet planes, they definitely use the jet stream to get to point A and point B a little bit more efficient, and they do not consume so much fuel when they're flying at that level because of the aid of the jet stream. Okay, that will also bring us to the end of our lesson today. Your homework is to ensure that you complete activity number 2. You come back ready for correction of those activities for our lesson or for our next lesson. Class, if you can now stand up. To the pilot teachers, our keyword for lesson 92 is Trophosphere. Good afternoon and thank you, students.